Okay, so obviously the next stage would be to try and solve some more complex differential equations, and what you'll notice is that, for example, in this one, it's very similar to some of the integration problems that you've come across before. So here we've got dy by dx equals x sine x, and there's no other information, so we're going to be finding a general solution, and so we need to find out what y is. So y is going to be the integral of x sine x with respect to x. And here we've got a product, therefore we're going to have to use integration by parts. To define which one I'm going to choose as u and which one I'm going to choose as dv by dx. Now it makes sense to choose this x term as u because once I differentiate it, it will eliminate itself to just 1. So that's the smart thing to do here. And therefore dv by dx is sine x. If I integrate that, I get minus cos x. And if I differentiate u as expected, I get 1. So now my integral has changed. It's now y equals uv, which is x multiplied by minus cos x. So minus x cos x minus the integral of du by dx multiplied by v, which is the integral of minus cos x with respect to x. That's quite simple to integrate now, so I get y equals minus x cos x plus sine x. Now because we haven't got any further information, I need to put in my constant term, and this is where having your constants starts to become very crucial. In the past you may just have been quite flamboyant about whether you put them in or not. It's very important that they now come in, obviously if you're integrating for a second time. And that would be the general solution for this particular question. Y equals minus x cos x. Let's put that x in for you. Minus x cos x plus sine x plus c. So I've got one to throw at you now, and one for you to have a go at. You might assume which method you need to use. So now's a good time to pause, have a go, and obviously watch the solution only once you're done. Okay, so hopefully you've had a chance to have a crack at this question. So let's go through the solution. Y is obviously going to be the integral of x e to the 2kx by 3 with respect to x. And we realise again we've got a product, so we need to use integration by parts. U equals x, and dv by dx equals e to the 2kx over 3. Therefore du by dx equals 1, and v equals 3e to the 2kx over 3 all over 2k. Substitute that in for integration by parts, and we get y equals u times v, which is 3x e to the 2kx all over 3 all over 2k, minus the integral of du by dx multiplied by v, which is the integral of 3e to the 2kx over 3 all over 2k with respect to x. Form that integration. And you end up with 3e to the 2kx all over 3 all over 2k multiplied by 3 over 2k. So i.e. you're dividing by the derivative of the power, because obviously it's an exponential term. And don't forget you've got your constant c in there as well. If we simplify that down, we get 3x e to the 2kx all over 2k minus 9e to the 2kx all over 3 all over 4k squared, which you can finally simplify down to, through factorisation, y equals 3e to the 2kx all over 3 all over 2k, open brackets, x minus 3 over 2k plus c.